This replication step tries to take a zero-sum two-player Markov game, a soccer game. I clearly follow the paper unless this is unstated. This is implemented using the bar lab. I used a 4Q learner, a single agent Q learner, and 3 multi-agent Q learner. 4Q tried to obtain minimax equilibrium policy. The Frank Q assume rule functions are equivalent. And the correlated Q tried to achieve correlated equilibrium, which coincides with the minimax equilibrium in a zero-sum game. For the ordinary Q learning, I decay epsilon from 0.1 and I decay learning rate from 1. Everything else is in the paper. The field Q have to use the multi-agent Q learner with a backup operator min-max Q. Everything else is the same as ordinary Q learner except epsilon was set up as a 0.2. Front Q is the same as FQ, full Q, except the backup operator becomes max Q. The CQ is the same as full Q, except that the backup operator becomes a UCQ learner. This is reproduce ordinary Q learner. Very similar chain as the original one, except my oscillation is greater. This is a reproduced front Q figure. Similar train, it just converge to the wrong thing because front Q doesn't work for the zero-sum game, and my convergence is much faster than the original. This is a reproduce the full Q similar train, but mine has greater oscillation and it converges slower than the original. This is a reproduced CUQ, very similar as the original one, though it was supposed to be identical, mine is not. And I would consider this in the main because of some implementation imperfection. Overall, I consider my replication effort successful. The difference in the reproduced and original figure are mainly due to different choice on the parameters, implementation method, and the method for raw data processing and plotting. Here are several example people and our work comes in. First, I have to figure out how to apply single agent ordinary Q learner for multi-agent game. And second one, initially my full Q and CQ crashed a lot, and later on I figured out to use a 32-bit Java SDK and replace the default LP solver with a GLPK. And also I set up the time constraint for the LP solver. Initially I made a mistake. I used the provided decay function for the learning rate within the game, which is not right, and I later on I corrected decay the learning rate between the games.